the latest sessions that we're having. So our first speaker is already there, so I won't wait longer and introduce him. Our first speaker of the day, as I said, is Radovan Miucic from Lear Company. He's the director for connectivity systems and system engineering at the Lear Corporation, and our first speaker of today with the topic sensor fusion with V2X and 5G connectivity, emerging ADAS applications. I will now stop my screen sharing and introduce him to us. So Radovan, you should be able to speak now, and you should be audible. Radovan, hello.
Hello.
Perfect. Hello.
Can you guys hear me?
Yes.
Okay, good. Can you see my screen?
Yeah, now we can see it.
Okay, good.
All right. Can you switch it to full screen mode for it?
Yes, I will do that. Sure. And does it show well?
Yeah, perfect.
Good. Okay, well, thank you very much for the opportunity to talk, and welcome to my presentation. I'll be talking about V2X and 5G connectivity, linking it with ADAS applications and so on. So first, I will start with some kind of motivation why we need more safety. It's estimated that there's 1.3 or more million fatalities a year globally as a result of road crashes and traffic-related injuries. Just in the US in 2017, there was about 37,000 fatalities and over 2.3 million injured. And this is a statistics from 2014. There's a significant travel delay, although that might not necessarily be true now in a virus condition, but in a normal, when there's normalcy, we have a lot of delays. It's estimated to be something like 5.5 billion hours. Another statistics from China, the World Health Organization estimates that road fatalities in China are over 250,000 a year. Now, if you look at the trending statistics of the traffic fatalities over the few decades, we can see that the blue lines, blue bars show the vehicle occupants. The vehicle occupants fatalities are slowly started to decline and plateau around 25,000, but occupants like a motorist or cyclist or pedestrians have been kind of steady numbers and even growing. Now, comparing the vehicle occupants and vulnerable road users, this graph shows that vulnerable road users is rising as a percentage of overall fatalities in traffic-related fatalities, which kind of these are new requirements for, or these are the emerging needs for protection of not only the vehicle occupants, but also vulnerable road users. As people become more health conscious, the people more cycle, they bike and walk and so on. There's a need to include them in the safety portfolio safety applications. Now, as far as the composition globally, so I picked 3 countries: US, China, and Germany. In the US, it's still the predominantly is the 4-wheel vehicles that are dominating the statistics for fatalities, and to lesser extent the pedestrians the cyclist, motorcyclist, and so on. China is completely different picture. In China, four-wheel vehicles are making a less percentage-wise statistics, and it's quite diverse. There is a motorcycle vehicles, almost motorized two and three wheelers comprise the majority of the fatalities, and then pedestrians as well. So just tells us that different regions of the world have different road participant compositions that needs to be addressed. And then in Germany, Germany looks a little more like US, but it's also have more motorcyclists, two or three wheelers, and pedestrians compared to the US. Okay. So when we talk about connectivity, we can think of connectivity as different things. So it can be a connectivity between vehicles, which I will focus the most. It's the direct communication vehicle to vehicle, or vehicle to the infrastructure. Maybe traffic signs directly talking to the vehicles, but also it can be a vehicle to vehicle using multi-hop, which is which is popular in European standards, but not very. It was not adopted in the US, and then the vehicle to infrastructure to another vehicle. That's a through, let's say, a cellular tower, or we can talk about some applications sitting on a server where the vehicles are talking through infrastructure to server. Server does some cloud application and then returns some aggregated data back to the vehicle. So different communication modes apply to different purposes. So for example, the hard safety, real time, what's going on right here around me is what the V2V direct communication intends to address, like electronics emergency brake light, forward collision warning, intersection mitigation assist, and so on. The infrastructure to vehicle broadcast can be the soft safety, which can include signal phase and timing, map, traveler information message, information about construction zones, and so on. V2V multi-hop, that's also sort of like a soft safety. This will be something informing a vehicle about some kind of hazard ahead that is, let's say, a kilometer or two or a couple of miles away from the vehicle itself. And so on. So there are different levels of latency requirements as well as availability requirements. So for hard safety, it should be on a channel that is low latency and high availability. The V2V direct communication should not compete with consumer electronics, internet access, and different kinds of connectivity needs. It should be on a channel that vehicles should access with low latency and high availability. Okay, so and then comparing the different sensors for ADAS, as well as the autonomous vehicle and safety safety of the vehicle. I have listed here kind of major categories of sensors, like a camera, radar, lidar, ultrasonic, and V2X. And I have listed the plus or benefits and sort of challenges with these sensors. So, for example, a camera has a very good angular accuracy. It has a very good market penetration. It is very mature solution. It does not depend on the positioning like a V2X does, and it does not depend on others having cameras. So it's independent sensors, and that's true for all sensors other than V2X. Radar is good to do a distance measurement, velocity measurement at night, different weather, It's a mature solution. It's in independent sensors, and so on. LiDAR is not so mature. It's not, market penetration is still very, very, very small, but it's really good in doing the distance, velocity measurements, and so on. Ultrasonic is a very short distance sensor. It's mature, its market penetration is very high, it's independent sensors, and so on. But all these sort of vision-based sensors, either camera or line of sight based sensors, camera, radar, LiDAR, ultrasonic, they generally perform worse with distance. So I'll give an example of a LiDAR. So let's say you have a LiDAR mounted on a vehicle, and you're detecting a vehicle that is maybe a couple of meters away from you. You'll get a lot of LiDAR points, and from that you're able to distinguish that's a vehicle, that's maybe a sedan, its orientation, and so on. But what if you're talking to or what if you're detecting a vehicle that is, let's say, 200 meters away from you? Then you get only a couple of points of LiDAR returns. Then you will not necessarily be able to judge that that's a vehicle or that's a pedestrian or something like that. You'll have a lot less accuracy in your judgment estimation of what that vehicle is. So, and that's true with almost all camera, LiDAR, ultrasonic sensors, but that's not the case with V2X. As long as you receive a message from another vehicle, you're able to understand it to the fullest, what that is, where that is exactly, and so on. And V2X is the only sensor that can work in non-line of sight. No other sensor like camera, LiDAR, radar, ultrasonic can do vehicle detection around the corner, behind a big truck, or so on. It's very also a benefit of V2X is a kind of understanding the remote vehicle intent, and I have a slide later on to clarify my thoughts there. But V2X can say, hey, I am about to turn left. I have my blinker on. V2X can be extended to share the destination route and so on. So the a remote vehicle intent is very difficult to judge with typical sensors, but it's much easier to do it over V2X. Again, awareness sharing. So camera can only see what it can see and sends that vehicle sends that information to the vehicle to use it and process it. But V2X can let's say understand the world around itself and share that information over V2X the same way host vehicle understands all other remote vehicles are able to understand. But there's some challenges with V2X. The market penetration is still very, very low. The maturity because of that is not as high as some other sensors. It does depend on GPS, and it does depend on others being equipped with V2X solutions. And I will also address one application we're developing in Lear to address this dependency on others being equipped, which is, I think, very, very interesting to look at. Okay, so unique benefits for V2X is highlighted here. So it doesn't degrade with distance. It works in non-line of sight. It can share a remote vehicle intent, and awareness sharing is a true benefit of V2X. Okay, so I will give you one example of why V2X is kind of strong, and it's sort of a hidden gem of sensors. So let's say you have on the left-hand side, you have a LiDAR. LiDAR returns a lot of points. And let's say the situation is you are a blue car and you're detecting a yellow car that is about to turn left. you get a lot of returns, point cloud returns. So what you need to do, you need to do a ground removal, you need to do a point cluster, you need to do point cloud segmentation, object detection, object tracking, finally do the target classification of the vehicle, and then get object data to your algorithms to use. Now, on the V2X side, on the right-hand side, if you have both vehicles equipped with V2X, the front vehicle, the yellow vehicle, will say, hey, I'm in front of you. This is my size, this is my speed and direction, and I'm about to turn left. So you directly get usable object level information from V2X compared to all these different steps you had to do with LiDAR to get usable object data for the algorithms. Okay, so moving on. If you have a vehicle entering, another example is if you have a vehicle entering the highway, so to negotiate the traffic using traditional sensors might be a little bit challenging, whereas if you have a vehicle to vehicle, then it can be done in more collaborative way. Perhaps the red vehicles can leave a gap for the yellow vehicle to enter. Okay, now I'm coming back to the concept of collaborative perception, and this is intended to bridge the gap of some vehicle equipped versus all vehicles equipped. And the concept is the following. So imagine just a simple scenario. 3 vehicles. The vehicle number 1, V1, it does not have V2X. Vehicle number 2, V2, has V2X and camera, and V3 just is like a V2X vehicle. So the vehicle V2, using a camera, can detect a non-V2X vehicle, and then it can act as a proxy for V1, informing everybody around that there is a vehicle, V1, its position, speed, and whatever is able to be picked up from the camera, acting as a proxy. So V1 sends information about its, V2 sends information about itself and about a detected non-V2X vehicles. So to the vehicle V3, it looks like everybody in this picture is connected. So V3 can do the B2V cooperative safety applications, just like all 3 vehicles would be equipped. Okay, so I'm going to move on. So that concept can be also expanded, not only using a camera, but it can be used using a LiDAR or radar, or maybe even incorporate infrastructure which detects the pedestrian using a camera mounted on infrastructure, and then acts as a proxy of that to the vehicle. Also, it can be maybe a Bluetooth detected vehicle, and so on. Okay, so I'm going to talk, the next topic is on a V2V enabled platooning, and this is a sort of like a mixture of V2V communication and autonomous driving. And the concept is vehicle V1 sends a path history points of its path, and this is V1 is driven manually, and vehicle V2 is autonomous vehicle that autonomously follows the path history points of the vehicle V1, maintaining the distance and maintaining the path of vehicle V1. There's number of useful applications. For example, let's say you call Uber, and instead of one car, you get 2 cars, but 1 driver. That's one example. Or maybe it can be a medical emergency, and then you call somebody to just come in front of you and wirelessly tows you to the safety. Or there's a number of different things that can happen, and maybe the biggest, most interesting platooning is in trucking industry, where trucks can be driven in platoon mode, and there's a number of startups that are already doing things like that. Okay, so I'm going to talk a little bit about the block overview of different logical components. So in the left-hand side, we have a communication, either DSRC or CV2X, TCU, 4G, 5G. Then we have a sensing section with GPS, GNSS, IMU, maybe a differential GPS, maps, camera, lidars, and radars. All that is being fed to the sensor fusion. And we have a local dynamic map that kind of thinks where we are on a map, who's participant in the map. We do then object detection, object classification. We assign high fidelity models for sensor-based objects. We do object tracking, classification, target filtering, and taking only the objects that are needed for kind of more general, actually not general, but for the actuation phase, which is the last phase, which consists of planning, their strategic, tactical, and behavior planning. Strategic is, you can think about analogy of, like, let's say you have a Google map and you want to go to a destination, so that would be a strategic planning. Tactical planning is you have multiple lanes to get to your destination, and you pick which lane you want to go to reach your strategic goal. And then behavioral planning is, you have to change lanes. How do you do that? You have a number of path curves that you are to try to follow. So the behavior planning takes care of that. And then finally, the control is actually an execution. Lateral control is how you maneuver your steering, and longitudinal control is how you maneuver your brake and accelerations. Okay, so why platooning? Platooning lowers fuel consumption, can add to traffic efficiency. There's a number of useful scenarios I mentioned before, and so on. So what we have a V2V communication modules. We have a precise positioning modules, and we would like to have an OEM partner to fully develop this idea. In my past experience, I have developed platooning when I used to work for a car company, but I will not show a video of that now in the interest of time, but this is kind of the idea of what we want to do. Now, in the interest of time, I will fast forward because I think I'm coming to an end. So I'll fast forward these things. So we have, for platooning, we have a localization needs that are different than a V2X general warning application needs. If the platoon, if the position is not accurate, then the vehicles can be offset from one another, and this is no longer platoon. It doesn't work very well. So the one way is to fix this with higher accuracy positioning. Another one is to do a sensor fusion between a camera and positioning to correct the not a camera, but sensor-based devices to correct for inaccuracies in positioning, and so on. In general, we identified several levels of the positioning needs. The V2X needs about 1 meter accuracy or 1.5 meter accuracy to position a vehicle in a correct lane. For level 2 autonomous vehicle, maybe 50 centimeter accuracy is good. For level 3, 20 or even less than that. So we have an EXO solution in Lear that is a hybrid of PPP and RTK, and this is something that we provide as a solution to the OEMs, and it's a higher accuracy positioning, and namely the so I'll skip this. Namely, this is the accuracy of our solution. So we have for low cost EXO is about 40-50 centimeters. For high performance EXO is 10 to 20 centimeters. Okay, so with this, I will skip the overview of connected pilots, and I will talk briefly about the V2X DSRC. So on the top, we had before allocation for the DSRC. So we have 75 megahertz allocated for DSRC-based V2V or V2X, but recent NPR from FCC sort of kind of changed that a little bit and allocated temporarily a usage of this space for Wi-Fi, and reduced, at least in United States, reduced the space for V2X to 3 channels of 10 megahertz, out of which 2 of them are thought to be for CV2X, and then 1 is maybe a mixture between either CV2X or maybe DSRC. So this is how the spectrum looks like nowadays. And in conclusion, V2X has been tested by many deployment pilots. V2X unfortunately is shrinking in US. V2X works well with other sensors. There is a high need for V2X and even for ADAS and autonomous vehicle systems, and V2X is a unique sensor that offers non-line of sight intention sharing, and I showed you how it actually is to get to the object level. You do not necessarily need a high computation. It's not a high computationally demanding system. Okay, with this, I will stop my presentation and open floor for a few questions.
Well, thank you very much, Radovan, for the input and for your presentation. Of course, now, as you said, we'll continue with our little Q&A session. Our next speaker is already there, so it will be only a couple of questions. But of course, if you have more questions for Radovan, just feel free to go over our app and just send them to him directly. But nevertheless, one of the questions that we got was, what do you think remains the biggest challenges when it comes to platooning? I think that's rather a broad one, maybe looking into the future.
Yes, that's a great question. The biggest challenge for platooning is overall for autonomous vehicle is safety. But in platooning, if the platoon is, let's say the vehicle in front is driven manually, then the perception and safety awareness is done by a human, and then the vehicles that are following are a little less burden on the safety. So I think that's a sort of a benefit for platooning. So for platooning can sometimes or a little bit avoid this safety aspect of autonomous driving, which is the major concern for overall autonomous driving. But the biggest challenge is probably adoption, the deployment. Yeah.
No, thank you. Another question that focuses more on 5G and the impact of 5G, I think, is what do you think will be the first step once 5G is, I would say, probably established more broadly? What is the first step? What do you think is like the biggest benefit of a 5G network up and running in most, I would say, developed countries in sense of the development of autonomous driving?
Yeah, so 5G is a mixture of different things, and it's probably, I don't really like that term, but it's like a marketing thing, and encompasses broad range of things. So the biggest benefit is when the communication becomes it goes into higher frequency spectrum, which means that the cells will be much smaller, and there will be a lot more infrastructure. Cells will be smaller, but it'll be much more higher bandwidth, so that there will be much more ability to share things with environment, with the cloud, with each other. So the benefit comes from just expanding the band, and in more applications can come into picture. For example, like operating a vehicle through teleoperation, and that may be one of the things for autonomous vehicle to work better. So for example, a vehicle is in situation where it cannot handle autonomously the situation, and that control is being transferred to somebody sitting remotely and operating a vehicle remotely, and 5G is technology that would be able to enable that kind of stuff.
Thank you. One last question that we got was, I think, on one of your last slides. Why do you think is it that V2X is shrinking in the US?
Because it took forever for V2X to start deploying, and even now it's not so deploying. So people said, hey, either you use it or lose it, type of deal. So it's really, the whole automotive industry should start deploying stuff, and then we'll gain back the spectrum, or not lose it, because it's commercial in nature.
Thank you very much. Sorry, thank you very much. That will be it with the question, with the Q&A part. Thank you again for your inputs. As I said earlier, if you have more questions for Radovan, feel free to reach out to him. From my side, thank you very much, Radovan, for also for the Q&A session. And I would take back the screen sharing now for a second.
Sure. I just want to say, here's my email if you guys have more questions.
Okay. Either directly through email, or as I said earlier, I think you're also you can also reach out to him through our app. So both is possible. But yeah, thank you again. And yeah, let's